Sir, your mic is muted.
Hello. Now I'm audible.
Yes.
Yesterday we had a discussion on implementation of binary search tree, where we have seen the different traversal techniques, insert method, and also we had a discussion on deleting a node. And we discussed that there are three different possibilities of deleting a node: when a node does not have any child, when a node has one child, and when a node has two children. So we had a discussion on that. Then we started with the implementation of a search function, but we could not do it completely. So the search function is here now, and the requirement for the search function is what? We'll be passing the root of the binary search tree, in which we have to search a given key value. So the root of the binary search tree will be passed, and the key value to be searched will be passed to this method. The method is returning a pointer to the same structure, and the return value will be null if the given key value does not exist into the given binary search tree. Uh, Else, it will be a pointer to a node in which the key value is present. Okay. So either it will be returning an address of a node in which the key value exists, or it will be returning a null if the key value does not exist in the given binary search tree. Okay. So what we are doing into this, it is quite straightforward and simple because we are making use of recursion in this. So the first statement is to compare the key value with the root data of the root. So if they are equal, it means that we have found the node in which the key value exists. So we simply return the root, okay, because it equals to the data of root. Else, if they are not equal, then there is a possibility that either the key value is greater than the root data, or it is smaller than the root data. If it is smaller than the root data, then we need to search it into the left subtree. If it is greater than the root data, then we need to search it into the right subtree. Okay, and that's what we are doing. In the else, we are comparing if the given key value is less than the data of a root. If the given key value is less than the data of root, then we'll be doing the same search function. We'll be calling the same search function. So we need to search it, but now we'll be searching into the left subtree because the key value is less than the root data. Now, since the key value is less than the root data, so for sure, if the key value is present in the binary search tree, then definitely it is going to present into the left subtree. Okay, so we are calling the same function, but we are passing the left child of the root as a new root, and then the same key value. Else, else means the key value is greater than the root data. If the key value is greater than the root data, then we need to do the same thing, that is search, but now this time we'll be searching into the right subtree of a root. We'll be searching into the right subtree of a root, and that's why now we are passing the right child of a root as a new root. We are passing to the same function the right child of a root as a new root. Okay, and that's all done. Then in the else part, else means the root, if the root is not null, then only we'll be doing all this comparison and all this stuff. If the root is null, then we'll be returning null. Okay, it simply means that uh, you have found or you have searched the entire tree, and the given key value is not present. So in that case, we are returning a null value. Okay, so let's compile this code. It is already running. this is execution, and let me put some data. For example, the first data is 10, so it becomes the root. The second data is 15, so this becomes the right child of a root. And the third data is suppose 5, it becomes the left child. Then let me add few more data. So 15 and then say 13. So this becomes the left child of 15. And one more data, say 8, that becomes the left child of root and then right child of 5. So I go for in order traversal. So it shows me 5, 8, 10, 13, and 15. Okay. Now, when I go for the search, the fifth option, and suppose I want to search 13. So it says me that given key does exist. So the given key value is there. And suppose I go for one more search, and this time I search for 31. So it says me that the given key does not exist. Okay. So yes, it is doing both the kind of thing correctly. And suppose I go for one more search, and this time I want to search 8, which is on the left subtree of the root node. So yes, it says the key given key value does exist. Okay. And suppose I want to search again and say this time I want to search one which does not exist. So it simply says me that a given key does not exist. Okay. So yes, it is doing its task correctly. So this is the implement function. This is the implementation of search function. So the search function is done now. It is quite straightforward with the help of recursion. I'll show you it once again. If the root is not null, so if the root is not null, then only we'll be comparing the uh, key value with the data of root. And if the key value equals to the root data, then in that case return root. And else, if it is not equal, then it will be either smaller or greater. If it is smaller, if the given key value is smaller than the root data, then we'll be searching it into the left subtree. So we are calling the same search function, but for the left subtree. Else we are calling the same search function, but now this time for the right subtree. Okay, that's all. And if my root is null, so we'll be coming into the else part, and that time we'll be returning null. So the function is simple and straightforward. Then Then yesterday we also had a discussion on this, that if the tree is given to us, a binary tree has been given to us, not specifically a binary search tree, because in a binary search tree you have one additional condition of the value, that the value of the left subtree is smaller than the value of the root node, which is smaller or equal to the value of the right subtree. Okay, that is the additional condition. Now, in binary tree, you can have a data like this. So, non-numerical data can be there in the binary tree. Okay. Now, when you have non-numerical data like this in the binary tree, so it is important that we should properly do the traversals, whether it is in order, pre-order, or post order. So, yesterday we had a discussion on this. So, we have seen the in order traversal of this example tree, and we had this sequence, and then the pre-order traversal where we had this sequence, and likewise the post-order traversal where we had this sequence. Okay. Now, what we discussed yesterday, that there is a possibility that you are given or you are provided with two of the traversal sequences, and then you need to recreate or reconstruct a binary tree from those given sequences. Okay, so either a in order and pre-order sequences are given to you, or a in order and post order sequences are given to you, and you need to create a binary tree out of those given traversal sequences. Okay, uh, it becomes quite straightforward and simple if the in order is also given. To make it little tricky, what happens that in the examination, sometimes a pre-order and post-order sequences are given. In order is not given. So that time it becomes little tricky, but that can also be done. It's not that much hard. But when a in-order traversal is given to us, so it is quite simple and straightforward. So in order plus pre-order, or in order plus post-order. Okay. So if in order is provided, then the recreation is quite simple. If in order is not provided and pre-order and post-order are provided, then it is little tricky, but still you can do. It's not that difficult. So now what we'll be doing, we'll be doing some exercises wherein I will be giving you some sequences, and out of those sequences, you need to create a binary search tree. Or else what can be done that let me do it like this. That is also done. Let's take the same example. So what we'll be doing that we are provided with this in order sequence and this pre-order sequence. So let's create a binary tree out of these two sequences. Okay, start doing. You do it and let me know. Or what can be done, you keep on saying me, and then accordingly we can do this. Okay, so what is the root of the binary tree for this? A is the root of the binary tree. Why? Because a pre-order traversal is given to us, and in pre-order traversal, the first node is always the root node of the binary tree. If it is post order, then the last node would be the root node. Okay. In this case, we understand that A is the root of our binary search. Now we have A as the root of the binary search. Okay. Once yesterday also I said you, I am saying you again. Pre-order and post-order will be giving us the information which node is the root, of the entire tree and also the subtree. And in-order traversal will be giving us the information which nodes are on the left subtree and which nodes are on the right subtree of a given root. Okay. So in this case, now we come to know that A is the root. So we'll now see the in-order traversal. And here we have A. Whatever is on the left-hand side of A, whatever is on the left-hand side of A is a left subtree of A. And whatever is on the right-hand side of A is going to become the right subtree of A. Okay, that we need to understand. So now, what I can say that the left on the left side of A, you have the nodes H, D, I, B, E. We have the nodes H, D, I, B, E. So it's little difficult for me to write on this. I have H, D, I, B, E. Okay. And then on the right side of this A, we have F, J, C, G. F, J, C, and G. Ah, please bear with the handwriting. I'm doing it with my mouse, unfortunately. So now the question is what? That we have the root node, we have the right subtree of the root node, and we have the left subtree of the root node. Now, out of this given left subtree, and also out of this given right subtree, the question is which of the nodes is a root of this left subtree, and which of the node is root of this right subtree. Now again to find out out of H, D, I, B, E, which node is the root node, we will be going to our pre-order traversal. Okay. So we'll be always going to pre-order and post-order traversal just to find out which node is the root node. Now this is pre-order. So pre-order means root always comes. Post-order means root will be coming at the end. Okay. Now what we need to do, we need to see that H, D, I, B, E. Out of these nodes H, D, I, B, E, when I see my in-order traversal from this side, left to right, so in this direction, I need to check that which node is coming first out of this H, D, I, B, E. So H, D, I, B, E. So I can clearly see that B is coming first. Okay. Now since B is coming first, it simply means that B is the root of this left subtree. Okay. B becomes the root of this left subtree. So what I can do in the next step, this is my step one. In the next step, I can redraw a tree. So making A as the root, and then the left child of A is B. Like this, I can mark that B is the left child of my root node A. And then obviously, I will be again going into the in-order traversal, and I will see what is there on the left-hand side of B. So I can see that this is there on the left-hand side of B, and this is there on the right-hand side of B, out of this given nodes. Okay. So to the left of B, I got H, D, and I. And to the right of B, I have only one node, that is E. Now, since it is the only node, I will encircle it. It is the root of this right subtree. Likewise, in this FJCG, I will see which node is the root node. So again, I need to check for pre-order. Yeah, FJCG, which node is coming first? FJCG, FJCG. So C, F, J, G. So C is coming first. So C becomes a root. So C is a root in this right subtree. I can say C is the right child of A, and then F and J comes onto the left hand side because they are on the left side of C in the in-order traversal. So here I will be writing F and J, and on the right hand side of C I have this G. Okay, and since there is only one node, G, so I can simply make a node. I can simply write G into this. Okay. Then on this side, I need to see that out of this H, D, I, which is the root. Okay. So I will be going to the pre-order. So D, H, I. So D is coming first. It is pre-order. So D becomes the root. So D is the node, which is a child of B. And in order traversal, I can see here. And then the same sequence I have written here. So H is on the left hand side of D. And it is the only node. So I can simply make H as a node on the left hand side of D. And I is also the only node on the right hand side of D. So I can make up a node naming it as I. Okay. Then this F and J, these are remaining. So I need to see which is the root among F and J. So here I can see F and J. So F is coming first. This is pre-order. So F is the root. So I can simply encircle and say that F is the left child of C and J is on the right hand side of F as per the in order traversal. Over here I can see. So J becomes the right child of F. And this completes our tree. Okay. So this is how the entire tree is drawn. And if I simply remove the unrequired thing from this, this is my right child. And this completes our tree. Okay. Out into this. Please let me know if you have any doubt. So this is how a tree is drawn, and I hope that this is the same tree which we have seen. So likewise, if a post order and in order is given, so the post order will be used to find out which node is the root node, and for that, uh, we'll see the node which is coming at the end. So in post order, whichever node is coming at the end, that node will be treated as the root node. For example, as we can see into this, A is coming at the end, so A is the root node, and H is coming first, so obviously H is the leaf node. Okay, and again we can go back to in order and we can see which nodes are coming on the left subtree of the given root node, which nodes are coming on the right subtree of the given root. Okay, so I repeat it again. Pre-order and post-order. These two sequences are used to find out which node is the root node. I repeat, pre-order and post-order. These two sequences are used to find out which node is the root node. And in-order sequence is used to find out which nodes are on the left subtree of a given root node and which nodes are on the right subtree of the given root. And it is quite straightforward. If you know the root node in order traversal, um, the battery is drained off. question. How come at right of F? Can you repeat that part? Um, how come J came at right of F? Acha, how come J came at right of F? Okay, for this, you can simply see, interestingly, this message is there and my laptop is off. So J is on the right side of F because if you see in order traversal, if you see the in order traversal, now the screen is off because my presentation was running from my laptop. So if you have done it and if you see that the in order traversal sequence, so J is coming after F or J is on the right hand side of F. Now, since J is on the right hand side of F in the in order traversal, that's why J has become the right child of F. Is that clear, the key? Is that clear? Now, who is the host of this meeting? May I know? Which student has come first? Or if someone of you can stop the recording.